compare ourselves to. I always compare myself to my best buddy from high school, and I just hate to be around him because he's doing so much better than me. None of that's, well, it's not true that I hate to be around him. I just constantly try to emphasize ways in which I think I'm better than he is. So we want to add a little piece to this. So we're seeing constantly that what people seem to care about, in addition, I mean, your own income does matter. Beta 1 is positive. But people also seem to care a lot about where they are relative to a reference point. Now we're going to add a piece, which is that people seem to care more about losses relative to the reference point than gains, right? And now in terms of vision or pitch or size, this is not a relevant concept. But once we're into happiness or utility or money valuations, we can start to think in terms of losses and gains. So you've seen this with the Cornell mug experiment, right? Losing a mug appeared to hurt subjects by about 525 on average. Gaining one benefited them by 225. Apparently, they care more about a loss than they do about the same size gain. Now, there's some evidence, and this is on DSpace. I don't think this is one of the required readings. This also shows up in people's judgments of fairness, which is an issue that is of great interest to behavioral economists. So let's do this. Again, clicker. So again, I have two different versions of the handout. I believe they have the same number of pages this time. And each of you has a scenario. Some of you have scenario 1, some of you have scenario 2. I'm not going to read them. The question is, do you consider the situation in your little scenario to be acceptable or unfair? Fair, unfair, acceptable, unfair. All right, now, as you can probably guess, if you think about it for a moment, you'll see that I screwed this up. Because I need to collect your answers separately, don't I? Right. All right. I'm on a glide path towards being a serious, fuzzy-headed professor. Okay, everybody's got their answer? Fine. People with scenario 1. Okay, about half of you. 3, 2, 1, and stop. And people with scenario 2. Okay, 3, 2, 1, stop. Fine. Whoops, stop. So here's scenario 1. A shortage has developed for a popular model of automobile, and customers must now wait 2 months for delivery. A dealer has been selling these cars at list price. Now the dealer prices this model at $200 above list price. So this is an inward shift in demand, which predictably should, right? Am I right about this? An inward shift in supply, right? So supply shifts in, and price goes up, or the price that you can potentially, right? So there's a restriction in supply, so you can get away with charging a higher price. So this dealer's been selling at list. Now they're selling at $200 above list, okay, to make more money. Scenario 2. A shortage has developed for a popular model of automobile, and customers must now wait 2 months for delivery. A dealer has been selling these cars at a discount of $200 below list price, and now the dealer sells this model only at list price. Now, before I show you your answers, or the answers that were in the study, the answers in the study are not on your handout, right? Good. Don't turn it over. Come on now. Does anybody want to conjecture sort of the distribution of answers in the two groups in this classroom? Hang on a second, Alex. I'll go over here. Okay, so say your name? James. So James says that in scenario 1, people will by and large think it's unfair, and in scenario 2, more people will think it's acceptable. And I'm forgetting your name? Andrew. Both scenarios, 3 to 1 on both. Okay, let's see what actually happens. Here is scenario 1. Most people seem to think that that is acceptable, but fewer people think that it's acceptable when it's, more people think it's acceptable when it's B. So the direction was, you were right. Now, in the study that they did, I got to get rid of this. How do I get rid of you? I go there, I go here. So in Counting Connection Thaler's results, in scenario 1, the vast majority, and it was 4 to 1, Andrew, said it was unfair. Right? Why are you now going to jack up the price? Unfair. But the balance shifted towards 60% people saying it was fine in scenario 2, where the dealer had been selling below list initially. I would conjecture that the reason, so that you guys shifted in the same direction. My guess is that the reason that so many of you think that it's acceptable is because you're economists, and we've trained you for at least the last 2 years to be basically bloody-minded, self-centered, and harsh. And that's good. That's a success. We count that as a success. But by and large, ordinary people think that whether or not this is fair, you get the point, which is that the outcome is the same for all parties. Right? Obviously, if the dealer was selling at $200 below list, it's because that's what they considered to be the profit-maximizing level given the demand that they were faced with at the time. Right? And if there's free entry into this market, they're at zero economic profit anyway. So nothing is different between these two scenarios. For the producer, they get an extra $200 per unit for a short period of time. Likewise for the consumers. But we think it's unfair. Why? Because there's a reference point involved, right? Which is the list price. Does that sound right? Is that what we're seeing here? Okay. Car dealers and manufacturers manipulate that list price in all kinds of annoying ways. Buying a vehicle is horrible. Okay. Now we're going to actually... So that's me presenting you with mostly findings from the field of psychology. Lutmer is an economist. I want to make an observation here. So you see the name Kahneman showing up over and over again. Kahneman and Tversky were the people who first introduced reference dependence and loss aversion into economic modeling in a paper called Prospect Theory, which is online. It's one of the required readings, or did I change that? It's on there, though. And they were psychologists, and they started out studying vision. They weren't studying economics at all. They were studying vision. And they got from vision to, hey, this shows up elsewhere, too. This is really interesting. And they turned themselves into, methodologically, economists, which I think is, what I like about that is that the founders of behavioral economics actually aren't economists. But they did sort of transform themselves methodologically into economists and use the methodology of economics. We're now going to see an extremely simplified version of the economic model that they came up with to incorporate reference dependence and loss aversion into standard microeconomics. Okay? And you'll be surprised and delighted by how simple it is. All right. Usually we model utility as a function of the level of consumption. All right, fine. All we have to do to get reference dependence in there is that we will model it in terms of the difference between the level and some reference point. Okay, so we have to have a number to plug into. Right, utility is a function of a bunch of variables, consumption of this, that, and the other thing, your income, etc. So we just have to have a number to plug into the utility function. So instead of plugging in your actual consumption, we're going to plug in how far away your consumption is from some reference point, whether it's above or below. Right, so that'll be a positive number if you're above, negative if you're below. So this captures reference dependence. Fine. And we could imagine all different shapes of utility function. But we're going to start with a very simple one that will help us to move forward. we model utility. This is crucial to what they did. We model both utility and reference dependence separately for each dimension of consumption, right? So mugs, candy bars, money, trips to space. So we then define the difference between consumption level and reference point for each different sort of piece of the bundle of goods that goes into your utility function. That distinction, that separation, so that I'm feeling gains and losses in mugs as well as gains and losses in money, turns out to be crucial. And you're going to see in problem 2 of the first problem set why exactly that's crucial. Okay. And finally, we assume that people have loss aversion, because we see it in so many different places, which is to say that the marginal disutility of a loss, how much utility you lose for each unit of consumption below a reference point, is greater than the marginal utility of a gain. Okay? So here's where things get super simplified. This is what is referred to as a toy model, and there may only be 3 other people in the world who use this term, but I call this a Ravenesque toy model. And the reason it's called Ravenesque is because I and a good number of other people in the world learned this approach to behavioral economics from Matt Raven, and Matt Raven is famous for his toy models. So I'll show you the toy model, and I want to say something about how simple it is. So what do we have here? The utility function is now a function of, I draw circles around too many things. It's a function of, okay, let me back up a second. So to apply this to the situation at hand, we will say, for example, this is the mugs dimension of utility, and this is the money dimension, because we're about to go back into mugs and money. So the utility function now, right, it's a function of consumption as usual. These are what are referred to as choice variables. We don't know them in advance. And then there's a semicolon here, after which we introduce a couple of fixed parameters, right, exogenous parameters. These are parameters of the utility function. They are not choice functions, right? So you have to know a person's reference point before you can actually write down their utility function. That's why those variables, R1 and R2, are after the semicolon. The semicolon separates out choice parameters from fixed exogenous parameters, okay, or choice variables. And so the specific functional form we're going to work with is that there's some value function v, and your utility is, first you take where you are relative to the reference point on mugs, plug it into the value function, where you are relative to your reference point on money, plug it into the same value function. And here's the key. The value function is a piecewise function. In this case, it's piecewise linear, and it goes like this. V of x equals x, so it's just a 45-degree line, if x happens to be greater than 0. Now, when we say v of x, what we're talking about is x is the argument of v, and the argument of v is c minus r, right? So what we mean is that if c minus r is greater than 0, if you're above your reference point, then the value function is just a 45-degree line straight up. Marginal utility is 1 for 1. Okay? Meanwhile, if the argument of the value function, c minus r, is below 0, that's to say if your consumption is below your reference point in either of the domains, then the value function is 2x. It's steeper, right? So it's like this if you're in the domain of losses. It's like that if you're in the domain of gains. Now, I'll just draw that, because my arm is probably not that great of a pedagogical device. Can you guys mostly see if I draw with the CD chalk? Okay, so I'm going to draw this value function on a full Cartesian quadrant. You'll see why in a second. Normally, we would have mugs here, right, and utility here. But instead what I'm going to have is I'm actually going to have c minus r, not the consumption level here, but where you are relative to the reference point. Okay? So the reference point will be here at the origin, that's 0. And then if you're above the reference point, you have c minus r positive, and if you're below, you have c minus r negative. Okay? And then the vertical is going to be v of c minus r. Now, v we can think of, we call it a value function because it's sort of like a subcomponent of a utility function. But we can think of it as being measuring utils. It's a measure of utility. And then we're going to take the utility you get from mugs and the utility you get from money, add them together, and that's here. So we can think about v as a form of measuring utility. So the way this value function looks, yes, question in the back.
So that can be C1 or C2, right? Like, like
yes, and I'm actually going to put 2 of these on the board because there's going to be a value function for each dimension. And by the way, the value functions for each dimension don't have to be the same. And indeed, in the problem set, you'll see that they are subtly different in the 2 different dimensions. So thank you for that point. Yeah. So the value function, if you're above 0, if you're above the reference point, is just v of c minus r is equal to c minus r. And then if you're below the reference point, it's 2s. V of c minus r equals 2 times c minus r. Okay? And then so you could say, I should have drawn this, right? So you could say this is the value function for mugs, and then we're going to have another one over here for money, and we can model these 2 things. So this would be c1 r1 and c2 r2, v of c2 r2. Fine. And then you could vary these things. What's crucial here is the fact that we're modeling relative to a reference point and the fact that there's a kink. Okay? So, yeah. Let me clear the decks here. So what's going on here, right? The basic concept of reference dependence is just captured in the fact that we're subtracting off the reference point from your consumption. And the basic concept of loss aversion is the fact that losses count twice as much as gains, which shows up as this kink. Another way to think about this, right? This is a cross-section of the utility function, right? So utility function is multidimensional. In this case, it has the mugs dimension, the money dimension, and then the utility dimension going up vertically. So this is the cross-section in the mugs dimension, which means that the slope of this thing is what? How much utility you get for a gain in... It's the marginal utility. So this is as you go up, right? Because basically moving this way, you can forget about the reference point for a second. This is getting more mugs, right? And this is getting more utility. So fortunately, more mugs is always better. That's good news. But what's happening is that gaining mugs when you're below, like say you start out below your reference point, getting mugs, catching up to your neighbors, for example, is much more valuable to you, and then your marginal utility goes down sharply. Now we often model utility as having, we often model sort of decreasing marginal utility like that. So it's not new to think that at a certain point, as you go from not very many mugs to more mugs, your marginal utility would go down. What's different is the kink. Okay, it's what happens right at the reference point, losses versus gains. That kink is what's going to drive so much of what we observe in the realm of reference-dependent preferences. Okay, yeah. Well, so same thing. So next question was, what happens if the reference point changes? You get some mugs and you sit for a while. So first of all, that comes up in the problem set, and it's the $64,000 question in this domain of behavioral economics. what defines the reference point, how does it change over time, how do people adapt, do they adapt. When I'm not hanging out with my friend Rick, I don't think about his income. And then suddenly when I have him over, and I'm like, oh, I just have this crappy old Weber barbecue and he's got some nice propane, right? So it changes, right? It's highly changeable. You saw this in a mug experiment. Presumably people's reference point for mugs, for Cornell mugs, was not, I own a Cornell mug. And then you put one on their desk and all of a sudden they're like, I'm now a mug owner, right? Hands off my mug. 5 minutes for the mug. Where's this coming from, right? You saw with the psychometrics. Like, I show you a black square or a white square. So it's A, it's easy to manipulate. B, it's a big open question. Where does it come from? How does it change? We're going to talk about that, I think next week or the week after. But it's a crucial question. Yeah. Go ahead. Did you have a follow-up? No. Okay. Yeah. Can V be defined? It can. The crucial feature of V is the kink. So if you think that there's a dimension of consumption, some good, for which there is no reference dependence, that would be, you'd be altering this model. Doesn't mean it would be wrong. You might very well believe that there's some dimension of consumption that is not subject to reference dependence, in which or loss aversion rather. And you could go ahead and model. People might have stronger, bigger kinks, more loss aversion in some domains than others. All of that is open to exploration. Okay. But the kink is crucial. The thing I want to say about this, and this is sort of a methodological point. If you go and look at the prospect theory paper, what you'll find is that their value function actually is a bit more complicated. It looks like this. Okay. So it's concave in each direction. Whatever, it's curved, but in opposite directions, okay? And so they have this idea that what they're capturing here is what they call, so normally we would say, oh, this is diminishing marginal utility. What they say is this is diminishing sensitivity to changes, okay? So if I love this example, this probably is from one of their papers. If I ask you to place a value on having to carry a heavy suitcase 1 block versus 2 blocks, your answer is probably going to be a lot bigger than if I ask you to place a value on the difference between carrying a heavy suitcase 20 blocks versus 21 blocks, right? So that's just a simple example of what I mean by diminishing marginal utility. And we have this idea that the further you get away from the reference point, percentage increases don't matter as much in either gains or losses. Yeah? So this sort of extends on next question. That's Alex. That's Nick. That's James. That's Andrew. Because it comes back to the question of what's the reference point. And one of the problems with this model, and I don't want to talk about this too much because I've got a whole lecture on it, is this model doesn't tell you where the reference point comes from. You have to assume what the reference point is, and it's going to vary. I mean, and intuitively, you know, the reference point depends on a lot of things. If I say, I'm now giving a chunk of next week's lecture. If I say, I'm going to give you a raise in a month, and then a week before that I say, you know what, I'm not going to give you your raise. You can be darn sure that your reference point is not your current income, and I can tell you how I know. I have actually had that happen. It was horrible, and I'm totally satisfied with my income now, right? Because my reference point is adjusted, as long as I'm not hanging out with Rich. The thing I want to say, the thing I originally wanted to say, this is a very, very, very simple model, right? There's no way that your value function is linear. No way, right? That some kind of diminishing sensitivity isn't in there somewhere. The idea that V would be the same, right? We have the same definition of the value function for mugs and for money. Obviously wrong. The thing that I want you to keep in mind is that our goal here at first is just to learn some lessons. What does this model accomplish for us? What can it predict that previously we couldn't predict? What predictions, what intuitions can we gain from this? And once you've sort of extracted, and this is precisely how the methodology of economics works across the entire field, you start with the simplest possible model, right? You start with the simplest possible, you strip away as much as you can and see what you can learn from the simplest possible model. Then you start to sort of make more sophisticated, complicated variations in your assumptions and the shape and form of the model to see what else you can learn. This is going to turn out to be a perfectly adequate toy model for us to learn quite a lot of lessons. In particular, buying and selling prices for mugs. Okay? So for those of you who've already started on the problem set and we're beating your head against the wall, by the end of this next couple of slides, you're going to be really wishing you had just waited until this lecture to start working on the problem set. That's typically going to be the case. You should take a look at it, see what you can do. But if it's just like, oh god, this is way over my head, just see if maybe waiting until the next lecture is helpful. Okay, so here's the setup. C1 and C2 are going to be consumption of mugs and money. R1 and R2 will be the reference point for mugs and money, respectively. And then we have this utility function. And the only way in which I've changed it from what you saw on the last slide was that I've added a 4, right? So that the value function, effectively what I have done is that I've got a different value function for each of the 2 different dimensions of consumption, sort of. I'm going to write it down so we can refer back to it as we go on to other slides. So, anyone see a trash can? When things are dead, throw them away. Okay, so U of C1, C2, given R1, R2 is equal to V of 4 times the number of mugs you have, minus 4 times the number of mugs in your reference bundle, plus same value function applied to the amount of money you have relative to your reference point, where V of X is equal to, this is piecewise, so you may want to think about what you've learned about how to solve a system of equations when one of them is piecewise function for X less than or equal to 0. And then some people will say, well, what happens right at 0? And then you can go and figure out the answer to that question, right? Because, well,